Right, please write measuring instruments not practical spherometer, practical determination of the radius of a curved object. So what is the subheading here? Practical determination of the radius of a curved object. Write the heading. Right. Put number 1 and write. Put number 1 and write. It is checking. It is checking whether the instrument has any zero error. It is checked whether the instrument has any zero error. It is checked whether the instrument, put number 1 and write. It's checked whether the instrument has any zero error. Star point and write. Star point and write. The instrument is placed on a horizontal surface. The instrument is placed on a horizontal surface. The instrument is placed on a horizontal surface. And the disc is rotated. The instrument is placed on a horizontal surface. And the disc is rotated. The instrument is placed on a horizontal surface and the disc is rotated until the screw touches the horizontal surface. Until the screw touches the horizontal surface. Until the screw touches the horizontal surface. The disc is rotated until the screw touches the horizontal surface. But stop. When all the supporting, same point, when all the supporting legs and the middle screw, when all the supporting legs and the middle screw eye contact with the same horizontal surface. When all the supporting legs and the middle screw are in contact with the same horizontal surface. Same horizontal surface. Come on. Come on. If there is no any gap, if there is no any gap between the main scale zero line, if there is no any gap between the main scale zero line if there is no any gap between the main scale zero line and the circular scale disc, main scale zero line and the circular scale disc, comma, The instrument does not have any zero error. Comma. The instrument does not have any zero error. The instrument does not have any zero error. Full stop. Next star point. Next star point. If the instrument has a zero error, next star point. If the instrument has a zero error, comma, the error is noted and practical is continued. The error is noted and the practical is continued. The error is noted and the practical is continued. Get here? Number two. Number two. The middle screw is rotated few cycles. The middle screw is rotated few cycles to move the screw upward. The middle screw is rotated few cycles, comma, to move the screw upward. So, okay dear, earlier the supporting legs and the middle screw, all of them were at the same horizontal level. Now what do we do dear? We rotate the screw several cycles to move the screw upward. Number three. The instrument is placed on the given curved surface. The instrument is placed on the given curved surface. Look at board. So here I have drawn two supporting legs. Okay, dear? So A and B are two supporting legs. Now the middle screw, it will be somewhere here. Okay, dear? Draw the figure. We have placed the instrument on the given curved surface. Right? So this is the position. Draw it. Right, now we have placed the instruments on the curved surface. I have drawn only two supporting legs. Actually, the third supporting leg is also in contact with the curved surface. So I have not drawn the third leg. But now the screw and the curved surface. Look at the screw and the curved surface. There's a gap between the screw and the curved surface. So what should we do next? The supporting legs and the middle supporting legs are in contact with the curved surface. But the middle screw is at a few distance above the curved surface. So what should we do next? Somebody? That's it. What should we do here? We should rotate the screw until it touches the curved surface. Otherwise, we can't get any measurements, right? Put number 4 and right. The screw is rotated. The screw is rotated. The screw is rotated until it touches the curved surface. The screw is rotated until it touches the curved surface. The screw is rotated until it touches the curved surface. Look at what. So we rotate the screw until it touches the curved surface like this. Now look at what. Right, let me draw this point and draw another perpendicular. Actually, I am drawing radii. I am drawing the radii. This is the center. This is the center of the curved surface. So these are radii. Radii make 90-degree angle with the curved surface. I think you know that maths, right? So this is capital R. This is capital R. This is also capital R. So we are going to find the capital R. But the measurement, the only measurement that we can take is this height h. We can find only the height h. And the other known thing is the distance between any two supporting legs. That is simple a millimeter is known. Okay, dear? So if the instrument does not have any zero error, reading of the instrument is equal to h. If the instrument has an error, by adding or subtracting the error, we have to find the value of simple h. So what is the only thing we get in this instrument, only measurement? The gap between the horizontal level of the legs and the tip of the middle screw. Simple h is the only distance, only measurement that we take in this figure, in this practical, right? Draw a new figure. Do not edit the previous one. Draw a new figure. Start. Right. So H is the only measurement that we take. Who wants more time to the figure? Please complete. Right. Number five. Number five. The reading of the instrument is noted. Number five. The reading of the instrument is noted. The reading of the instrument is noted. With the star point and right. Star point and right. If the instrument does not have any zero error, if the instrument does not have any zero error, if the instrument does not have any zero error, comma, the reading of the instrument is equal to the height symbol H. Star point and right. If the instrument does not have any zero error, if the instrument does not have any zero error, comma, the reading is equal to the height symbol H. Height symbol H. Full stop. Same point. If the instrument has a zero error, if the instrument has a zero error, comma, the height symbol H, the height symbol H has to be calculated. The height symbol H has to be calculated, by adding or subtracting the zero error. The height has to be calculated by adding or subtracting the zero error. Get here? Number six. Number six. The radius of the curved surface. The radius of the curved surface. The radius of the curved surface. Within brackets capital R. The radius of the curved surface within brackets capital R can be found by the following equation. The radius of the curved surface within brackets capital R can be found by the following equation. Please write this equation here. Write this equation and draw a box around it. Please remember that no need to prove this equation. You can directly use this equation in the exam. The examiners never ask you to prove this equation. If you want, you can prove, but it is out of syllabus. What is simple area? Simple A equals the average distance between any two supporting legs. Any two supporting legs. Right. Put 3 star points and write. 3 star points and write. The following experimental procedure. The following experimental procedure is used. The following experimental procedure is used to find the following experimental procedure is used to find the average distance between any two supporting legs. The following experimental procedure is used to find the average distance between any two supporting legs. To find the average distance between any two supporting legs. Number one, they will ask you to write these experimental steps, right? So there is a certain procedure, experimental procedure to find the gap between any two supporting legs. Okay, dear? Right. Number one, a white paper is placed on a horizontal table. A white paper is placed on a horizontal table. A white paper is placed on a horizontal table. Number two, the given spherometer is placed on the white paper. The given spherometer is placed on the white paper. The given spherometer is placed on the white paper. Number three, the instrument is pressed towards the white paper. The instrument is pressed towards the white paper. The instrument is pressed towards the white paper. Full stop, same point. Full stop and write the same point. Then three small holes. Then three small holes are formed on the white paper. Then three small holes are formed on the white paper, comma. Then three small holes are formed on the white paper, comma. Due to the tips of the supporting legs, tips. Then three small holes are formed on the white paper due to the tips of the three supporting legs. Due to the tips of the three supporting legs. Look at board here. So if this is the white paper, once you place the instrument on the paper and once the instrument is pressed towards the paper, three small holes are formed on the paper like this. Can you understand here? So these three holes are A, B, and the third leg C because of the tips of the three supporting legs. So what should you do next here? You take the instrument away, join the three holes by three straight lines, and measure the lengths of the three straight lines. Okay, dear? When you measure, almost the three lengths will be equal. But sometimes the distances may be A1 millimeter, A2 millimeter, and A3 millimeter. There may be very small differences. There is no very big differences. If there's a very big differences between A1, A2, and A3, it means the distances between supporting legs, the instrument has some of it. There should be very small differences between the distances between the legs. Got it here? Draw this figure. This is the white leg. Draw the figure. So then, how do we measure A1, A2, A3? Our student says using a vernier caliper. Is it easy? may be accurate, may be accurate. I agree. Yes, some students argue with me. When we use a vernier caliper, the vernier caliper has a smaller least count, therefore the accuracy of the measurement is larger. I agree. But is it easy to use vernier caliper to measure A1, A2, A3 distances here? No. So what is the easiest instrument here? Use a meter rule. Number four, that the distances between the supporting legs. The distances between the supporting legs. The distances between the supporting legs within brackets A1, A2, A3. The distances between the supporting legs within brackets A1, A2, A3. Comma. Sorry, close the bracket and write. Are measured by using a meter rule. The distances between the supporting legs within brackets A1, A1, A2, A3, close the bracket, are measured by using a meter rule. Clear? And now leave a line and write this equation. Look at board. Now leave a line and write this equation. It's a big equation, so I have written the equation. This sentence already on the board. The average distance between any two supporting legs equals A1 plus A2 plus A3 divided by 3. Am I right here? Write this equation, draw box around it. The average distance between any two supporting legs equals A1 plus A2 plus A3 divided by 3. Right, Lama, listen to me here. This equation R equals A square over 6H plus H over 2. This equation is correct. Even the curved surface is into the other direction. Can you understand it? Let's say the curved surface is like this. Even for this kind of a curved surface, then the legs will be like this. The supporting legs will in contact with the curved surface like this. Even the curved surface is like this, right? Then the height edge is this. This equation is valid. Clear here? If the curved surface is into the, if it is the divergent curved surface, then it is okay. The same equation can be applied whether the curve is an upward curve or a downward curve. I'm not going to give you a note for it. Let's try for a, now we can try for a past paper question.